We live in a galaxy called the Milky Way, an empire with hundreds of billions of stars.
How did we get here, and what's our future? In every way, those questions involve galaxies.
There are 200 billion galaxies in the known universe, each one unique, enormous, and dynamic.
Galaxies are violent. They were born in a violent history. They will die a violent death.
Where do galaxies come from? How do they work? What is their future? And how will they die? This is our galaxy, the Milky Way. It's around 12 billion years old. The galaxy itself is a huge disk with giant spiral arms and a bulge in the middle. It's just one of a huge number of galaxies in the universe.
Galaxies are first and foremost large collections of stars. The average galaxy may contain 100 billion stars. They're really stellar nurseries, the place where stars are born and where they also die.
The stars in a galaxy are born in clouds of dust and gas called nebulas. These are the pillars of creation in the Eagle Nebula, a star nursery deep in the Milky Way. Our galaxy contains many billions of stars, and around many of them are systems of planets and moons. But for a long time, we didn't know much about galaxies. Just a century ago, we thought that the Milky Way was all there was. Scientists called it our island universe. For them, no other galaxies existed. Then, in 1924, astronomer Edwin Hubble changed that thinking. Hubble was observing the universe with the most advanced telescope at the time, the 254-centimeter Hooker, on Mount Wilson, near Los Angeles. Deep in the night sky, he saw fuzzy blobs of light that were far, far away. He realized they weren't individual stars at all. They were whole cities of stars, galaxies, way beyond the Milky Way.
Astronomers had an existential shock. In 1 year, we went from the universe being the Milky Way galaxy to a universe of billions of galaxies.
Hubble had made one of the greatest discoveries in the history of astronomy. The universe contains not just one, but a great number of galaxies. This is the Whirlpool Galaxy. It has 2 giant spiral arms and contains about 160 million stars. Galaxy M87, a giant elliptical galaxy. It's one of the oldest in the universe, and the stars glow gold. And this is the Sombrero Galaxy. It has a huge glowing core with a ring of gas and dust all around it.
Galaxies are gorgeous. They represent, in some sense, the basic unit of the universe itself. They're like gigantic pinwheels twirling in our space. It's like fireworks created by Mother Nature.
Galaxies are big. Really, really big. On Earth, we measure distance in kilometers. In space, astronomers use light years, the distance light travels in a year, which is just under 9.5 trillion kilometers.
here we are 25,000 light years away from the center of our galaxy, and our galaxy is over 100,000 light years across. But even that, as large as it is kind of a speck in the cosmic distance scale.
Our Milky Way galaxy may appear big to us, but compared to some others out there, it's actually pretty small. Andromeda, our nearest galactic neighbor, is over 200,000 light-years across, twice the size of the Milky Way. M87 is the largest elliptical galaxy in our own cosmic backyard, and much bigger than Andromeda. But M87 is tiny compared to this giant. 6 million light-years across, IC 1011 is the biggest galaxy ever found. It's 60 times larger than our Milky Way. We know galaxies are big and they're everywhere. But why is that?
One of the very big questions we have in astrophysics is where galaxies come from. We really don't have a complete understanding of that. The universe started in what we call a Big Bang, an extremely hot, extremely dense phase, about 13.7 billion years ago. We know that nothing like a galaxy could have existed at that time. So galaxies must have been born, they must have formed out of that very early universe.
It takes gravity to make stars, and even more gravity to pull stars together into galaxies. The first stars formed just 200 million years after the Big Bang. Then gravity pulled them together, building the first galaxies.
The Hubble Space Telescope has allowed us to peer back in time to almost the dawn of time. A period when galaxies have just begun to form.
The Hubble telescope sees lots of galaxies. But the light we see today from those galaxies left them thousands, millions, even billions of years ago. It's taken all that time to reach us. So what we see today is the ancient history of those galaxies.
When we look at the Hubble Deep Field, what we see are little smudges. They don't look much like the galaxies we see today. They're just little smudges of light that we can barely discern. Those smudges of light contain millions or billions of stars that have just begun to merge together.
These faint smudges are the earliest galaxies of all. They were formed around 1 billion years after the beginning of the universe. But that's as far back as Hubble can see. If we want to go even further back in time, we need a different sort of telescope, one too large to launch into space. But now we have one, in the high desert of northern Chile. This is ACT, the Atacama Cosmology Telescope. At 5,190 meters, it's the highest ground-based telescope in the world.
I really like working in the extreme environment of ACT. It's very, very cold often, and the wind blows violently. But the good thing about it from our point of view is that the sky is very, very clear almost all the time.
Clear skies are important for ACT's precise mirrors to focus on the earliest galaxies.
With ACT, we're able to zoom in with unprecedented detail on parts of the sky. We can also study the progress of growth of structures, where structures are things like galaxies and clusters of galaxies, with the very fine scale detail.
ACT doesn't detect visible light. It detects cosmic microwaves from the time the universe was just a few 100,000 years old. The telescope not only detects early galaxies, it actually sees how they grew.
we're able to track the progress of the formations of galaxies and clusters of galaxies. We see the footprints of all the galaxies that have grown in the time between when the universe was a few 100,000 years old till now.
ACT has helped astronomers understand how galaxies have evolved since almost the beginning of time itself.
And we can start answering the question, what did galaxies look like when they were young? How did they compare with modern-day galaxies? How have they grown?
Astronomers are seeing how galaxies evolve from groups of stars into the network of systems we see today.
Our current understanding is that stars form clusters that build into galaxies, that build into clusters of galaxies, that build into superclusters of galaxies, the largest structures we observe in the universe today.
Early galaxies were a mess. Lumpy bunches of stars, gas, and dust. But today, galaxies look neat and orderly. So how do chaotic galaxies transform into beautiful elliptical and spiral galaxies? The answer is gravity. Gravity shapes galaxies and controls their future. There's an unimaginably powerful and incredibly destructive source of gravity at the heart of most galaxies. And there's one buried deep at the center of our own Milky Way. Galaxies have existed for over 12 billion years. We know these vast empires of stars come in all shapes and sizes, from swirling spirals to huge balls of stars. But there's still a lot about galaxies we don't know.
How did galaxies come to have the shapes they do? Was a spiral galaxy always a spiral galaxy? The answer is almost certainly no.
Very young galaxies are messy and chaotic, a jumble of stars, gas, and dust. Then, over billions of years, they evolve into neat, organized structures, like the Whirlpool galaxy. Or our own Milky Way.
Our Milky Way began not as a single baby galaxy, but many. What is now our Milky Way was once comprised of lots of small structures, irregularly shaped objects that began to merge.
What pulls the small structures together is gravity. Gradually it pulls stars inward. They begin spinning faster and faster and flatten into a disk. Stars and gas are swept into huge spiral arms. This process was repeated billions and billions of times across the universe. Each of these galaxies looks different, but they do have one thing in common. They all seem to orbit something at their center. For years, scientists wondered, what could be powerful enough to change how a galaxy behaves? Then they found out. A black hole. And not just any sort of black hole, but a supermassive black hole.
The first clue that supermassive black holes existed was that at the heart of some galaxies, there was an immense amount of energy emanating out from the center. What we're seeing is the black holes and these galaxies feasting on the material around them. So it's like having a huge Thanksgiving dinner.
The meal is gas and stars, and it's being consumed by the supermassive black hole. But sometimes black holes devour too quickly, and what they're consuming is discharged back into space in beams of pure energy. It's called a quasar. When scientists see a quasar blasting from a galaxy, they know it has a supermassive black hole. But what about our galaxy? There's no quasar here. Does that also mean there's no supermassive black hole? Andrea Ghez and her team have spent the last 50